dear students. In the previous video, we already discussed about the chemical properties of PCl5 and PCl3 and also acids of phosphorus. In this video, I am going to explain a new concept. It is about 16 group elements. Group elements. Yes. Remember students, these 16 group elements are also called as chalcogens. These are also called as chalcogens. Why these elements are also called as chalcogens? See here, these are ore forming. These are ore forming elements. 16 group elements are ore forming elements, therefore they are also called as chalcogens. Remember, this general formula or general electronic configuration of 16 group elements is a rare gas NS2 NP4. General electronic configuration of 16th group elements is rare gas NS2 NP4. ಈ ಒಂದು 16ನೇ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ಸ್ ಗೆ ಚಾಲ್ಕೋಜೆನ್ಸ್ ಅಂತ ಕೂಡ ಕರೀತಾರೆ. ಯಾಕಂದ್ರೆ ಅದರ ಮೀನಿಂಗ್ ಓವರ್ ಫಾರ್ಮಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್, ಅದು ಅದಿರು ಉತ್ಪಾದನೆ ಅಂದ್ರೆ ಅದಿರನ್ನ ಹೊರಡಿಸುವಂತಹ ಎಲಿಮೆಂಟ್ಸ್. ಜನರಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಫ್ 16th group elements is rare gas NS2 NP4. Now I write the elements which are present in 16 group elements and particular atomic number, electronic configuration of the elements. Okay, see here. Okay, here element here atomic number and electronic configuration. This one are the elements present in 16th group. The first member is oxygen, another one sulfur, selenium, tellurium and polonium. Yes, the first member of 16th group element is oxygen. Because of this point, this is also called as oxygen family. Yes, oxygen atomic number is 8 and sulfur it is 16, selenium 34, tellurium 52 and polonium it is 84. Yes, electronic configuration. Helium 2s2 2p4. Here neon 3s2 3p4. argon 3d10 4s2 4p4 and tellurium krypton 4d10 5s2 5p4. Next, here xenon 4f14 5d10 6s2  6 6p4. Yes, these are the electronic configuration of particular elements. Now, practice this because it is very important. Come to the point of occurrence. Occurrence of the 16 group elements. Which one is the first member here? Oxygen. Remember, oxygen is available in diatomic form, means it is existing O2, and it is one of the most abundant element on the earth, 46.6% by mass on the earth's surface. And usually dry air, it contains 21% of air, means oxygen. As oxygen, it is one of the most abundant element present on earth, 46.6% by mass on earth. And dry air, it contains 21% of oxygen. Next, sulfur. Usually sulfur, it is found in sulfates. It is found as sulfates, sulfides, and other suborganic materials. Sulfur, it is also available in combined state. For example, sulfur exists in combined state in the form of ores. If we take an example, PbS, lead sulfide, or also called as galena, and zinc sulfide, ZnS, zinc sulfide, HgS, mercuric sulfide. These are some examples of ores which contain sulfur. Yes, when you come to the point of sulfur, I told you, sulfur exists in combined state, and it also exists in presence of native state. It is available in the form of S8, and this sulfur also available in the gaseous form. In gaseous form, if you take an example, H2S, hydrogen sulfide, it is available in gaseous form. Next, another point. Which one? Selenium and tellurium. Remember, these elements, selenium and tellurium, these are less abundant and available in the form of metal selenides and tellurides. Remember, selenium and tellurium are less abundant and available in the form of metal selenides and tellurides. Is it right? Okay. Next, another one, polonium. Yes, polonium, it is one of the radioactive elements. It is one of the radioactive elements which having half-life period. Usually, it is obtained by the decay product of or decay of thorium and uranium. The decay product of thorium and uranium is polonium. Yes, this is about the simple occurrence of the 16 group elements. Then, now we will go to the physical properties of the 16 group elements. Physical properties. Physical properties of 16 group elements. Yes, we already know oxygen, it is available in O2 and O3 form. As you know, O2 means reaction and O3 means ozone. As oxygen, there is existing two forms, O2 and O3. One important thing which comes in presence of physical properties with respect to 16 group elements is all the elements present in the 16th group elements, they exhibit allotropes. Very important, remember this point. All the elements exhibit allotropes. All the elements exhibit allotropes. Why? See here. This oxygen, it is available in two forms, O2 and O3. And this sulfur, it exists in two forms. One is rhombic and another one monoclinic. Rhombic sulfur and monoclinic sulfur is up here. Means it also exists in two forms. Next comes the point of selenium. Selenium, it contains a number of allotropic forms. Selenium exists in both crystalline forms as well as amorphous forms. There is a several number of selenium allotropes. And tellurium, it is also appears in presence of two types. One is crystalline form and another one amorphous form. Next, polonium. Polonium, it contains two types of allotropes. One is alpha polonium and another one beta polonium. Yes. Because of this point, I take an important point. All the elements exhibit allotropes. All the elements exhibit allotropes. Okay, these are some physical properties. Next, come to the point of general properties. General properties of 16th group elements. General properties of 16th group elements. In that first point, atomic radius. Atomic radius. What happens if you move down the group in presence of 16th group elements? As what is atomic radius? It is the distance between the nucleus and outermost electron. Students, see here. If we move down the group, what happens to the atomic number? Here, atomic number increases. Due to increase in the atomic number, the number of cells also increases. Is it right? Yes. Due to increase in the atomic number, the number of cells also increases. It indicates the distance between the nucleus and the outermost electron is also increases. Even though ಪರಮಾಣು ಸಂಖ್ಯೆ ಹೆಚ್ಚಾಗ್ತಾ ಹೋದಂತೆ ಅಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಸೆಲ್ಸ್ ಏನಾಗ್ತಾ ಹೋಗ್ತದೆ, ಸೆಲ್ಗಳ ಸಂಖ್ಯೆ ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೆ. ಯಾಕಂದ್ರೆ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ, ಸೊ ಸೆಲ್ಗಳ ಸಂಖ್ಯೆ ಕೂಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತದೆ. ಸಂಖ್ಯೆ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತಿದೆ ಅಂದ್ರೆ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತೆ ಹೊರ ಕವಚದಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಡಿಸ್ಟೆನ್ಸ್ ದೂರ ಏನಾಗ್ತಾ ಹೋಗ್ತದೆ, ಅದು ದೂರನೇ ಆಗ್ತದೆ. ಹೌದಾ? ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೆ. ಅದಕ್ಕಾಗಿ ಅಟಾಮಿಕ್ ರೇಡಿಯಸ್ ಏನಾಗ್ತದೆ, ಹಾಗಾದ್ರೆ ಅದು ಹೆಚ್ಚಾಗ್ತಾ ಹೋಗ್ತದೆ. If we move down the group, the atomic radius increases. Yes, atomic radius, it increases. It increases down the group. Next point. Electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy is the amount of energy released when an electron added to the outermost cell. electron gain enthalpy, that is the amount of energy released when an electron is added to the outermost cell of an isolated gaseous atom. Yes, what happens to the electron gain enthalpy if we move down the group in presence of 16 group elements? Yes, no doubt it decreases down the group, because if we move down the group, number of cells increases, and number of cells increase means the distance between nucleus and the outermost electron also increases. Therefore, at that time we can easily remove the electron. Therefore, electron gaining enthalpy decreases down the group. Decreases down the group. But when you observe the values of electron gain enthalpy of respect to these elements, oxygen is slightly more because of its compact nature. Yes, next another point. Third one, ionization energy. Ionization energy. What happens to the ionization energy in presence of 16 group elements if we move down the group? Yes, students, if we move down the group, atomic number increases, then ionization energy decreases. What is ionization energy? It is the amount of energy required to remove an electron of an isolated gaseous atom. Yes, it also decreases down the group. Similarly, another point, electronegativity. Electronegativity. Yes, what happens to the electronegativity? If we move down the group, electronegativity of 16 group elements also decreases. Remember, it also decreases down the group. One very important thing, remember here, among the 16 group elements, oxygen is one of the more electronegative atoms. Remember, in presence of 16 group elements, oxygen is one of the more electronegative element in 16 group. Yes, next another point, very important, oxidation state. Oxidation state. Students, remember, usually 16 group elements, remember this point, 16 group elements usually shows the oxidation state between -2, +2, +4 and +6. 16 group elements shows oxidation state of -2, +2, +4 and +6. Yes. Next, another point, see here, oxygen. Oxygen usually shows -2 oxidation state. Oxygen usually shows -2 oxidation state. But in presence of OF2, its oxidation state is +2. Remember, this is very important. Usually oxygen shows -2 oxidation state in several type of compounds. But in presence of OF2, it is +2. Oxidation state of oxygen in OF2 is +2. लागे सामान्यವಾಗಿ ಆಕ್ಸಿಜನ್ ಏನು ತೋರಿಸ್ತದೆ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ನಂಬರ್ ಅನ್ನು -2 ಅಂತ ತೋರಿಸ್ತದೆ. ಆದರೆ ಈ ಒಂದು OF2 ನಲ್ಲಿ ಇದು +2 ಆಗಿದೆ. ಯಾಕೆ ಇದು +2? ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಪಾಠ ಕಲಿಬೇಕಾದ್ರೆ ನೀವು ಅಲ್ಲಿ ಕೆಲವೊಂದು ರೂಲ್ಸ್ ಅನ್ನು ಕಲಿತಿರಬಹುದು. ಹ್ಯಾಲೋಜನ್ಸ್ ಆಲ್ವೇಸ್ ಶೋಸ್ -1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್, ಎಸ್ಪೆಷಲಿ ಫ್ಲೋರಿನ್ ಇಸ್ ಆಲ್ವೇಸ್ -1. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇದಕ್ಕೆ F2 -1 ಆದ್ರೆ ಎರಡು ಇದಕ್ಕೆ ಏನಾಯ್ತು -2 ಆಯ್ತು. ಹಾಗಾದ್ರೆ ಯಾವಾಗ ಈ ಓವರಾಲ್ ವ್ಯಾಲ್ಯೂ 0 ಆಗ್ತದೆ, O ವ್ಯಾಲ್ಯೂ +2 ಆದಾಗ ಮಾತ್ರ ಓವರಾಲ್ 0 ಆಗ್ತದೆ. +2 - 2 = 0. +2 - 2 = 0. ಹಾಗಾದ್ರೆ OF2 ನಲ್ಲಿ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಫ್ ಆಕ್ಸಿಜನ್ ಎಷ್ಟಾಯಿತು? +2 ಆಯ್ತು. But and also in presence of H2O2 means in presence of peroxides it is -1. Why it is -1? See here, hydrogen oxidation number is always 1. ಎರಡು ಹೈಡ್ರೋಜನ್ ಅದು ಎಷ್ಟಾಯ್ತು? +2 ಆಯ್ತು. ಒಂದು ಹೈಡ್ರೋಜನ್ ಗೊತ್ತದ, ಒಂದು ಹೈಡ್ರೋಜನ್ +1 ಇದ್ರೆ ಎರಡು ಹೈಡ್ರೋಜನ್ +2 ಆಯ್ತು. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಈಗ ಇದು +2 ಐತಿ ಅಂದ್ರೆ O2 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾದಾಗ ಓವರಾಲ್ ವ್ಯಾಲ್ಯೂ 0 ಆಗೈತಿ, ಅದ -2 ಆಗಬೇಕು. O2 ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಾಗಬೇಕು? -2 ಆಗಬೇಕು. ನಾನು O2 ವ್ಯಾಲ್ಯೂ ಬೇಡ, O ಅಷ್ಟೇ ಬೇಕಾಗಿದೆ. ಸೊ ಆಕ್ಸಿಜನ್ ಏನಾಗ್ತದೆ ಹಂಗಾದ್ರೆ -1 ಆಗ್ತದೆ. ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ರಿಮೆಂಬರ್, usually oxidation state of oxygen is -2, but in presence of OF2 it is +2, and in presence of peroxides oxygen oxidation state is -1. Yes, next point. If we move down the group, remember, if we move down the group, -2 oxidation state decreases. -2 oxidation state decreases, +4 and +6 oxidation number increases. If we move down the group, -2 oxidation state decreases, +4 and +6 oxidation state increases. Yes, polonium it shows +4 and +4, usually it shows +4 oxidation state. Remember this point, if we move down the group, these elements shows +4 or +6 oxidation state. Next, anomalous properties. Anomalous properties of oxygen. What is the meaning of anomalous properties? ಏನು ಹೀಗಂದ್ರೆ anomalous properties ಅಂದ್ರೆ ಈ ಒಂದು ಗ್ರೂಪ್ ನಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಜೊತೆ ಉಳಿದಿರ್ತಕ್ಕಂತ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ನಾವು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಆಕ್ಸಿಜನ್ ತನ್ನದೇ ಆದಂತಹ ಒಂದಷ್ಟು ವೈಶಿಷ್ಟ್ಯತೆಗಳನ್ನ ಅಥವಾ ವಿಶೇಷ ಗುಣಲಕ್ಷಣಗಳನ್ನ ಒಳಗೊಂಡದ. ಅವು ಯಾವುವು ಅಂತ ಯಾವ ನೋಡೋಣ. Oxygen compared with other elements it is small in size. It is right. It is small in size. Yes, because if you move down the group, atomic size increases. Therefore, oxygen is in small in size. Next, it has high ionization energy. What happens to ionization energy if you move down the group? Already we discussed. Yes, ionization energy decreases down the group. Therefore, oxygen has high ionization energy because of its small size. Next, third point, it has high electron affinity. Similarly, it has high electronegativity. It has high electronegativity. And another one, absence of d orbitals. When you observe the electronic configuration, there is no d orbitals present in the oxygen. Yes, these are some anomalous properties of oxygen. Along with this, you remember some concepts. These are very important. Hydrogen bonding. Remember hydrogen bonding. What is hydrogen bonding? It is a bond present between the hydrogen and one of the electronegative atom. Yes, hydrogen bond is present in presence of only oxygen containing compounds, but not other elements present in the groups. Yes, ಏನಂತ ಈ ಒಂದು ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಕಂಡು ಬರ್ತದೆ ಯಾವಾಗ ಆಕ್ಸಿಜನ್ ಒಳಗೊಂಡಿರ್ತಕ್ಕಂತಹ ಕಂಪೌಂಡ್ ಗಳಲ್ಲಿ ಮಾತ್ರ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಕಂಡು ಬರ್ತದೆ. ಅದನ್ನು ಬಿಟ್ಟರೆ ಉಳಿದ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ಸ್ ಇರತಕ್ಕಂಥ ಸಲ್ಫರ್, ಸಿಲಿನಿಯಂ, ಟೆಲೂರಿಯಂ, ಪೊಲೋನಿಯಂ ಯಾವುದೇ ಇರಬಹುದು, ಇವು ಇರುವಂತಹ ಕಂಪೌಂಡ್ ಗಳಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಕಂಡು ಬರ್ತದೆ. ಇದು ಅದರ ವಿಶೇಷ ಗುಣಲಕ್ಷಣ ಅಲ್ವಾ. ಸೊ ಹೈಡ್ರೋಜನ್ ಬಾಂಡ್ ಇಟ್ ಅಪಿಯರ್ಸ್ the compounds which contain oxygen only but not other elements which are present in 16 group elements. Next, another one, hydrides of oxygen is an example. H2O, hydrides of oxygen is in liquid form, hydrides of oxygen is in liquid form but others are in solid or gaseous state. Yes, here one important question. It may be asked in our examination. Why H2O is liquid, H2S is gaseous form? Yes, I think you know H2O is liquid, but H2S is gas. What is the reason behind this? Remember, students, this H2O, it contains oxygen. H2O means definitely it contains hydrogen bonding. ಈ H2O ದಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ಕಂಡು ಬರ್ತದೆ. ಅದಕ್ಕಾಗಿ ಇದೇನದ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್ ಅದ. Yes, H2O, it contains hydrogen bonding and bond enthalpy is high here. Bond enthalpy is high. But there is an absence of hydrogen bonding in H2S. Means in presence of hydrogen sulfide, there is no hydrogen bonding. Therefore, it exists in gaseous form, but water exists in liquid form. Yes, these are some anomalous properties of oxygen. Okay, students, in the next video, we discussed the chemical properties of the 16 group elements. Okay, thank you.